This is the CR-Scan Lizard from Creality, their brand new 3D scanner. Let's have a play. Hello and welcome to Making for Motorsport, where we make more, spend less and go faster. And if this is your first time here, we use DIY electronics, 3D printing and fabrication to make cars go a whole lot faster for not a lot of money. But we're not here to talk about that. We're talking about this, the CR-Scan Lizard from Creality. Let's have a closer look. So this is what we get in the pack. Now there might be different levels of pack that come out, so like an add-on pack. So you might have more or less of this, but one thing everyone will have is this, the scanner itself. So it's of a reasonable size. It's not too big, about 160mm by 80 by 50 millimeters. And it's got actually quite a nice feel to it. It's nice, symmetrical, clean design, but it's got a fair amount of gravity in it. It's got a bit of heft. It's got a real kind of, you know you're holding something. It's got a bit of quality feel to it because of that weight. So that's the main unit. What it comes with is a nice little tripod that just screws into the bottom on this tripod mount. The feet all stick out on this, and it also extends so you can get a bit of an angle down on your subject, and you can also flip it over for handheld mode as well, which I'll talk about in a moment. But that's all I've used for my scanning, and it's done the job very well. So what's also in the package is this little motorized turntable, and it spins at just the perfect rate for the turntable mode in the software. It's a micro USB socket, and which everyone's got at home, and Creality, however, have sent a very handy extra cable just so you've got that and you can plug it straight in. On top of the turntable goes the turntable pad, so that is used in turntable mode, and this would spin, rotating the object that we scan at the perfect rate. So you get a power supply that plugs into the data cable and all the different power sockets of the world, but we'll use the best one, ask Electroboom, the United Kingdom plug. There you go. So this is the data cable. It's about 2 meters long. On one end you've got the USB and the power supply, and on this end you've got the plug goes into the scanner, and this has got a nice kind of aluminium look to it. It's got some barbs there, so it's actively retained and gives you the little red dot, just like a camera lens, to give you the correct orientation, because there's one there in the socket, and it gives a nice click when it gets home, and it's in there for keeps, and that gives it a really nice kind of industrial feel to it, that that's in there properly and it's not coming out until you want it to. So Creality claim this device has highest precision, up to 0.05 millimeters. So that's 2 thou if you're into imperial, which is a lot. Now precision isn't necessarily accuracy, so we're going to test some of these claims with the models that we scan today. It can do down to 20mm cube, best starting about 80mm cube, around 150, and it does all the tracking without any markers or scanning dots being put onto anything. There is also a texture mode where you can scan items that have got a heavy texture or a pattern, and upcoming is an update that allows you to take pictures and project colour onto that. I don't have that available to me at the moment, so I'm not going to use texture mode. When it's out, I will probably do another video on it. Other things that Creality have said are that you can scan in the sun. Well, you won't see any videos of me scanning in the sun. However, I have done that in the run-up to this video, and I've got exactly the same results as you'll see on this video. So what are we going to scan? Well, first off, we've got the ubiquitous child's toy that everyone uses for their first scan. I believe it is actually the law. Number two, we've got some parts that people may recognise from some of my recent videos, and we've got a really challenging black plastic induction manifold with all of the detail, lots of surfaces, and that's going to be a real challenge for the scanner. So we'll see how it does with that in handheld mode. So once the software loads, you can see we've got a screen with loads of different sections to it. We've got a data panel over here. We've got a screen where we're going to see the scans here, a bit of a status idea there. We've got some different pages, and we've got the settings down here. So first off, you've got your different modes. So this is whether you're doing a geometry based scan or you want to really capture surface textures and finishes. Then we have whether you're scanning a small or a big object, and then you've got brightness. So one used for very bright objects, white objects, and four you can use for dark objects, and obviously 2 and 3 are for in between. And then frame rate, low, medium, high, fairly self-explanatory, but I tend to start at high because that gives me the best results. So we're going to scan good old little Rex here. So there's lots of detail on Rex, little cheeks have got some ridges in, we've got a parting line down the middle, we've got little hands there that are a slight relief, and we've got little dimples on his knees. So plenty of detail to pick up on Rex. So first off, we're going to save the project and save a new project. There we go. So these are my starting settings, and so we're going to go through the process step by step. So first job is to do a preview. So we click preview and then we pop Rex on the turntable. So I've already set up the scanner so it's in the right position, but you can see we're seeing most of Rex on here, a bit of the background. So I'm happy with how it's positioned, but we can just double check the distance. 300 millimeters precisely, which is exactly what Creality recommend. So we stop the preview and we go to the initial scan. So for that we remove Rex and click initial, and what this does is just give the scanner a clear view of the base plate. So you can see it's red. That means that it recognises it's the base plate and not the model, so it will be able to remove that from the scan at the end of the processing. There's no set time in the software for how long this should take, so I just let the table rotate one full way around. So once we're happy with that, we can just click stop, put Rex back onto the turntable and click scan. So once you do hit scan, you'll see the image as being scanned comes up here in the window. You can see the count of the frames being computed up here and the frame rate there, 10 FPS. And as it goes around, you can see the table being filled in and more data being put onto the scan. So that's it, scan's finished, about 323 frames. Once the scanner's finished, you can manipulate this window in much the same way as most 3D modelling software. So you can translate with the middle mouse button or click and drag for rotate. And that looks, there's a lot of data points there. You can see all these little points in the point cloud. But underneath, you can see we're lacking a bit of data underneath his chin. But what is good is that the base plate has been separated from the model, so the software knows that that's different. So we need to do another scan to get some data under there. So what we'll do is we'll do another scan. So we flip Rex over to put his chin up so we can see underneath his chin, so we give the scan a chance to get that detail. Click append, and with the same settings, click scan. And you can see the same thing is happening again, but with Rex in a slightly different position. So again, the software is just picking up all the points from the model, and you just let it do its thing. And we can do the same thing. We can have a look, and you can see that there's lots of data now on that chin area where we didn't have information before. So now we've got 2 scans. We can process them together. So we hit the process button, it loads the 2 scans, and because we know this is a solid model, we can also hit fill holes. So the first thing it's going to try and do is align the 2 scans automatically. And if we look at what it's done, we can see that it has failed. Now sometimes this does work really well, but not this time. So we can click manual alignment, and we can put alignment pairs on these models to pull them in. To make that easier, we click this button up here, hold Alt, and we can select one of the models. So to translate that out of the way, third mouse button, and we can drag him out, and then we can rotate him as you would in a normal 3D modeling package, and we can put him in that kind of environment so we can see both models in the same kind of orientation. So what we want to do is put marker pairs, so we join up the areas on the model that are the same. So first click marker pair, then we right click to lay them. So I'm going to put one onto his cheek there, and one onto his cheek there. There's no, and we'll do the same. So we want to create another marker pair. There's no need to be absolutely super accurate, because the software does do a lot of the work for us. There's another one on the dimple. We're just giving it a help. We're just giving the software a helping hand here. So then we'll do another one on this side, and we'll probably do, I think maybe corner of his mouth there. So we'll do another there, and that'll look like it's on the same place, but there you go. So you can see we've got 3 marker pairs, and once we've got 3 marker pairs, a line becomes available to click. So we click that, and now the software has put them together based on our instructions, and as you can see, that looks a lot better. So now we can just go hit next and let the software do its thing. Okay, so that's the software done. So we can click exit, and we can zoom in on him and have a quick look. So the feet look a little messy there, but you can see it's picked up a lot of detail around the snout. So what we'll do, we'll just do a quick bit of analysis of work on it. So we can do, there's all kind of tools here that's really worthy of a video all on their own, but what we can do is just apply this, the denosing smooth, which takes a small amount of time to run. And there we have a neat looking model. We've still got the detail on his arms, we've got the detail on his teeth. Now, as we can see, the feet are a bit messed up. And I think that's because on the actual model, the feet are a bit darker, which means they don't scan quite as well. So what we can do is we can take small bits of the model that don't look right. So if we just want to do a few little tweaks like this, these bit here, these claws don't look great. We can press Control and we can drag out sections of it. See, that's how that's red. We can come up to here on this tab and we can hit Delete Selection, Apply, and then we can do that to kind of tidy up. Again, hit Control, bits of the model that we know we don't like, delete selection, and then we can go back here and we can go back to Mesh Doctor and we can apply some fixes to kind of fix those areas, and we can click Fill Holes. So, and we can give it tangent, so we can click Fill Holes, and we can preview, so it picks up the holes and fixes the holes we've basically just made, and we can apply that to the mesh. So you can do a lot of little tweaks in the software, and then if we wanted to, we can then export this wherever we wish to go, directly as an STL or an object file. So if we wanted to export it as an STL, we'd send that direct to our slicer and then 3D print it. But we're not going to 3D print it. We're going to do some more analysis. So we're going to export it as an .obj format. I'm going to call it Rex model. And we're going to go measure it in Fusion. But not quite yet, because what we're going to do is redo the whole scanning process, start to finish, but taking a little bit more care and also using some developer spray. And when I say developer spray, I don't mean the fancy 3D scanning specific developer spray, I mean dry shampoo. And I'm going to squirt a bit of that onto Rex's feet to try and give the scanner a half a chance. Now, at this point, I think it's important to let you guys know that I am a complete noob when it comes to 3D scanning. I have never touched one, or at least a consumer grade one, in my life. So I've been totally dependent on the Creality instructions when I've had this, and it took a few days of playing around, but we're getting some pretty good results, as you can see with this scan of Rex. So if you're a noob, then this is kind of what you can expect. You'll have a few days learning curve, but if you're an expert, then please let me know what I've been doing wrong down in the comments. So just a little bit more care and attention on scanning, maybe trying one or two more, and a little bit of post-processing. You've got yourself a model there, which actually you could send straight to a 3D printer, and it's got all of the keyed into detail. It's got the split line, it's got the teeth in there, it's got the little hands, it's got the little dimples on the knees. I'm happy with that. So we've done a bit more of a textures and curvature model. I'm going to do something a bit more engineering based, a bit more numbers. So this is an idle air control valve from my project Siesta. If you want to see videos on that, check it up there. But we're going to do a scan of this. Now this is quite challenging because you've got some reflective surfaces, which I hear scanners don't get on well with, and black, which I also hear they don't get on well with. So maybe a bit of a challenge here. And actually I'm very interested in that flange, because I need to make something that's going to mount to that flange and work in the same way as the standard piece. So let's scan it and have a look. So you can see I've had to change the brightness setting. and it's kind of picking up, it's gone from 1 picking up nothing to 4 kind of picking up some, and also it feels to me like the scan isn't seeing all of it, but let's give it a go anyway. Now I think that's done quite well, so let's flip it over, do another scan of the other side, and see what kind of model it puts together. Shiny surface, black surface, really difficult for scanners, and I think it's done quite well. There's a bit of interesting surface texture, which I think if we did a denosing smooth would tidy right up. And there's the odd artifact here and there. In fact, we can easily take those away in a couple of seconds. But what this does do for me is give me the information I need, which is this face here. So now we've done a couple of scans, what we'll do is we'll throw them into the 3D modelling software and take some measurements. So my software of choice is Fusion 360, and I'm no good at all with the mesh commands or the mesh programs on it whatsoever. So this might be a little clunky, but we'll get it done. So first off, we're going to insert Rex. We use the first model we did, and don't ask me why he gets thrown in a silly orientation, because I haven't worked it out yet, but we'll be working on it. And then if you insert, get him about there, somewhere near the origin, and we're going to use millimeter because that means it's scaled correctly. So my computer's getting a little clunky now with the model this size. You can see there's plenty of detail, plenty of information in there. This was smoothed, so again we could probably go back, redo the scan, spend a bit more time, but we'll see what kind of results we've got out of this. So we're going to measure across his cheeks, from there to there, because it's pretty much the widest point. It's going to be the easiest to get some calipers on. To there. So Fusion says 38.28 millimeters. So if we measure with the calipers, you've got to be careful how hard I squeeze here. We're on 38.3736. So that's a total error of 0.01 of a millimeter in terms of accuracy. That's pretty good, pretty good. So let's have a look at the control valve. So this scanner's a bit messier. We could have probably used the developer spray on this, but we've still got some reasonably sharp corners here. Like there, you can see the corners are still relatively sharp. So that's when I take a measurement across. So what I'm going to try and do is take a measurement across the width there, and then the depth there. So we've got kind of X and Y. Okay, so we're going to try and put some measuring points across here. So we've got to be a little bit careful with where we put them. So that's about as good as we've got in terms of picking up those edges. And the software is saying 67.35 or 36. So if we put the calipers on the same dimension, and we've got on here 67.41. Oh, it's very difficult. Just changes slightly. 41, 42. So that is 0.07 of a millimetre. Very close. Right, let's look at across these points. Look in the opposite direction. Let's have a quick look. This angle, yeah, we're pretty much tracking the face there. So the software says 37.93, and we've got 37.96, 0.03 millimeters. Even closer. So quite honestly, I'm blown away. The idea we can get sub 0.1 millimeter, sub 4 thou accuracy from a consumer grade 3D scanner, it's amazing. Is it metrology grade? No. Is there going to be variation in the numbers? And when you look at the scan, if that was razor sharp, you'd have a bit more confidence, but we can spend a lot more time on the scans, on the developer sprays, on really refining the techniques and getting it perfect. But we know that we're doing that based on sound data in the first place. The measurements are pretty good. I'm impressed. So that's all the testing on the turntable done, and what I wanted to do was go down to the garage and scan some larger items. However, this laptop really isn't up to the challenge. Now, it ran the scanner, but it wouldn't crunch the numbers on the software. That's not surprising because this was 10 years old and it was pretty mediocre when I bought it back then. Most cell phones have got more power than this. So to give you guys an idea of what power you need, I'll put the specs for my desktop computer up here, which runs the software, no problems. And I'll put the specs for the laptop up here. So as long as you're closer to my desktop, you shouldn't have a problem. So instead of me going down to the garage for the oily bits, I guess the oily bits have got to come up here. And that's exactly what we're going to do. So we've brought a larger part up to the office to use in handheld mode. You've got exactly the same settings as you have in turntable mode, but you don't have to initialize the base plate. You just click scan, you get a countdown, and away you go. Now you must be really careful how you move it because you can lose tracking. And that's what happens here with the red bar. Now that really happens a lot when you're getting poor scanning. So I drop the frame rate down to low to try and give it a bit more of a chance. And that seemed to do the trick. So on a matte black plastic surface, we get a small amount of losing tracking there, but it picks it back up and carries on scanning, and it's picking up a reasonable amount of detail. But it's not perfect. So we do one pass and stop it and have a look at the point cloud. So handheld mode is trickier than turntable mode. You've got to maintain just the right distance from the part, maintain the right angle, and keep it the right speed so you don't lose tracking. It's very similar to TIG welding. That is not a good scan, so we're going to get rid of it. Now to try and give it a fighting chance, I have covered it in developer spray and changed my t-shirt. That might be the winning move. Delete that scan, click start scanning, and have another go. We get the countdown and we can see already on the preview it's looking a lot better. So we're picking up lots more detail, lots more information. Now, one of the downsides of putting the developer spray on is you have to drop the brightness level to 1. Now what that means is then you definitely don't pick up anything that doesn't have the developer spray on it. So if you can see holes in the model here, that's just area that doesn't have the developer spray on, or I've not given the scanner line of sight to actually scan it. If you give parts a much better spray in developer, you'd have a far more complete scan than this. And you can see there's the point cloud, lots of information, time to process it. You've got a chance to remove the ground there, and I've sped up a lot of the processing in this particular section of the video because the scans are bigger, there's more data, it does take longer. It's not unreasonable, but it is a couple of minutes. And there you have it. We've got some really nice surfaces, some really good detail. I think if we really went to town on the developer spray and really took our time over it, we could get a really good scan out of this part. So there you have it, guys. A few simple scans, but the results speak for themselves. Now, it may not make one of these redundant overnight, but what it will do is make measuring curves and capturing complex shapes really, really simple. And especially if you've got different measurements on different planes, you can relate those together very, very easily. If you're doing body parts especially, this will be really useful. Is it essential? Well, I'll let you make your own mind up about that, but certainly for me, it's going to be very useful in the future. Creality are going to do a Kickstarter campaign on the CR-Scan Lizard, so if that's something you're interested in, I will put the link down in the description, possibly up here, and if you're going to buy it, please use that description because it'll help support the channel. And I'm interested, you guys out there, what do you think of 3D scanning technology? Put your thoughts down in the comments. Are there any projects you'd love to use one on? Do you think you really need it yet? It's only a matter of time. These are great toys. That's it for this time, guys. So don't forget to check out the Patreon channel and the Kickstarter for the CR-Scan Lizard. Scan you later.